In the last video, we set up a Raspberry Pi with Void Linux and got it ready to host a personal web app. Today we're going to get that web app actually hosted on it and accessible from within our local network. And then in the next video, we're going to set up a VPN, which is going to allow us to securely access it from any external network without actually exposing the web app to others. Welcome back to this mini-series on self-hosting. I'm going to be picking up where we left off, so if you missed the last video and you want to follow along, I'd recommend starting there, but happy to have you either way. Let's get into it. This is the Git repo for the app we'll be setting up. The project is just a proof of concept. I'd like to incorporate something like this into Breezy one day, so I made a proof of concept to get some ideas from it. But for now, it's got a heaping spoonful of clunk that I wasn't able to iron out in my 3-day time box. You'll note that it needs both node and npm in order to run, and git as well to clone the repo. I'll be using nvm to install and manage my node and npm installations, so I've got that repo handy as well. If we jump down to its install command, we'll see it requires curl, which is yet another program we need to install. Let's head over to a terminal to get some of these prerequisites installed. I'm currently SSH'd into Void Linux on my Raspberry Pi as the primary Ben user. To install git and curl, I'm going to run this xbps install command. Note that this needs sudo privileges, so make sure to include that. Once that's finished, I'll head back to the nvm git repo, copy the installation command they provide. If I paste and run that within my terminal session, we can see that it says to close and reopen my terminal to start using nvm. So I'll go ahead and exit out of my SSH session, and then reconnect it. Using nvm, I'll install the latest version of Node. To make sure it's installed and working, I'll run node -- version, and whoops, looks like I'm missing a shared library. I can check xbps to see if it has the missing library available to download, which it does, so I'll get that installed too. If I can spell xbps correctly, that is. Okay, now if I run a node version check, it works. npm version does as well. With our prerequisites out of the way, let's create a Git directory to house our web app, change into it, and then clone our repo. I'm going to grab Git's HTTP URL rather than the SSH URL because I never actually configured my Void Linux with a GitHub key. And since this is a public repo, I don't actually need to authenticate anyway. The build steps for different applications are likely to be very different, but for this particular agenda app, I'm going to build it by changing into its front-end directory, running npm install, followed by npm run build, and then jump to its back-end directory and run npm install, followed by node index.ts. The node command actually starts hosting this web app, which we can confirm by heading over to a browser and go into our Pi's network address, followed by port 3000. For me, that's 10.0.0.120:3000, and sure enough, it's up. Now, back in the terminal, I'm going to push Control-C, which stops the running application so that we can get it configured as a system service. I'd mentioned this in the last video, but just as a quick refresher, Void Linux uses runit as its initialization system, which is what manages our services. The var service directory lists all the services we have enabled, and last time we added the WPA supplicant service to this list. The etc sv directory lists all the services that are configured and able to be enabled. We want to create a new one for Breezy Agenda. We're going to need to know two things for this. Number one is the web apps directory containing the main index file that we want to run. And number two is the full path to the node executable that's going to run it. We can get those by running pwd to print the current directory, and which node to see the full path of the node executable. To keep these values on the screen so that they're easy to refer back to, I'm going to open up a second terminal session on the right, SSH into my Pi, and then configure the service from here. First, I'm going to make a Breezy agenda directory inside my etc sv directory. This is where I'm going to create that file that tells runit how to run my service. Then I'll create and open that file using sudo. Note that the file must be called run. That name has special meaning to runit. This run file is really just a shell script. We're going to execute the chpst command, which stands for change process state. It lets us do things like change the user that the process runs as and the directory from which to run the command. And we're going to do exactly that. We're going to run this as the ben user and change into that backend directory we printed out a little bit ago. Now, if you remember, we use the command node index.ts to run our backend process. The runit script doesn't actually load our bash environment, so it doesn't know where the node executable is. And that's why we need to provide the full path to node. And then, of course, followed by the index file that we want to run. This run script needs to be made executable using this chmod +x command. If you don't, the service is going to get caught in a restart loop and there will be absolutely no indication anywhere as to why it's not starting. Ask me how I know that. So now that we've configured our service, let's enable it by creating a symbolic link to it inside the var service directory. We'll wait a few seconds, and then check its status with the sv status breezy agenda command. Looks good. So let's jump back to a browser, and hey, it's working. To show you how the Agenda app's data storage works, I'm going to create a test account in the Agenda app. I'll enter the username and password that I want to create, then click Create Account. If the credentials get cleared, then the account was successfully created and I should be able to log into it. But where does that account data get stored? So the Agenda app creates this data directory inside of our backend directory. The data directory contains a single encrypted file per Agenda user. The file is encrypted using the user's provided password, so when the user logs in, we attempt to decrypt the file using that password, and if decryption fails, then the password must have been incorrect. This is the only place the Agenda app stores any data, so this is the only place that we have to back up. My backup strategy will be to just copy this entire directory to a timestamped directory somewhere else on the system once per day. For any meaningful data, this is not sufficient. Meaningful data should follow the 3-2-1 backup process, which basically just means you should have 3 copies of your data stored on at least 2 different devices, one of which is stored off-site. What we're doing is more like 2-1-0, and will not prevent any data loss if, for example, my SD card fails. My main goal here is just to have a historic backup of my data in case the web app decides to crash, mid-encryption and ends up corrupting the existing data file. I'd just be able to restore the prior day's data file and move on. Anyway, to do this, I'm going to be using a program called Snooze, which is basically cron, but 1,000 times simpler, while still working for like 99% of the situations. I'll go ahead and install that using xbps install. And to make it run periodically, I need to enable one of these 4 services it gives us access to. I want daily backups, so I'll link the Snooze daily service to var service to enable it. Now, once per day, Snooze Daily is going to run every script it finds inside of the etc cron.daily directory. All I need to do is add a script in there that does my backup. My backup script is going to start off by defining a directory that houses all of my backups. Since these services run as root, I'm just going to put the backups inside of the root user's home directory to keep things simple. The agenda files are going to be inside a subdirectory with each day's date. So I'll create that directory and then copy over all the data files into it. The last step is to clean up old backups. If this is running for, the next 3 years, I don't need over 1,000 backups. This find command finds all the directories inside of /root/agenda backups that have been modified over 30 days ago, and then it just deletes them. That script needs to be made executable. And for good measure, let's actually run it manually to make sure it works. First, I'm going to switch over to the root user using the command sudo su - so that I can look at this user's home directory where we'll be actually saving the backups. Now I'll run our script manually. This is why it's good to confirm things. All right, let's edit our script again and delete that extra hyphen. Sorry about that. Okay. Now let's run it. Looks like it worked, and it created a backup for our test agenda account. I'm going to go ahead and delete this backup to make sure it doesn't interfere with the next time Snooze runs, since there's a non-zero chance that it's going to be on this very same day. We finished the second of 3 steps. The next video is the last video, the epic conclusion to this tale of mystery and excitement. We're going to be installing a VPN server, but not a commercial one like Nord or Express that supposedly gives you anonymity, but a private one, like what companies deploy to restrict access to their internal servers to just employees. So that should be out within a couple of days, and then after that we'll be back to our regularly scheduled Breezy devlogs with the goal of obsoleting everything from this mini-series. Anyway, hope you enjoyed, and I'll catch you in the next one.